All right, welcome back to the Supply Chain Planning Asia Summit. My name again is Max Henry. I'm your host for today's event. So I would like to introduce you to our next two speakers. Joining us are Suraj Kamath with the APAC Director, Industry Consulting, Manufacturing Solution for SAS. Also, we have Edward Katz with the Principal Analytics Consultant for City Global Solution. So both of them are going to be delivering a joint presentation. The topic for this presentation is called Redesigning the Supply Chain with AI, Cloud, and Dynamic Optimization. So we're going to hear from them first, and they will join us again for the live Q&A after.
Thank you, Max. It's great to be here. So today we're going to talk about redesigning the supply chain with AI, cloud, and dynamic optimization. And to speak to you here, there's me, Suraj Kamath. I'm the APAC Director of Consulting for Manufacturing Solutions at SAS, a leader in analytics. And I have with me Ed Katz, our Principal Analytics Consultant at CD Global Solutions, a SAS Gold partner that's been instrumental in delivering and driving many of our solutions in the supply chain space. Thanks for being here, Ed. So we're going to talk about today the need. So I'm going to go through a few minutes about the need for AI, all these three capabilities in supply chain optimization, and Ed's going to make it real for you in the next section. So today, one of the main reasons that's driving supply chain the redesign is the fact that the world is disrupted. One of the areas I come from is semiconductors. I've worked in semiconductors in the past for a very long time, and it's really interesting for me to see how semiconductors is now this link in the global supply chain that impacts everything from cars to toasters. It's today, with even as the pandemic eases, we're seeing new disruptions come out, like the war in Ukraine, and that's driving the supply disruption of neon gas. Now, you'd say, well, neon gas, do we really need that much of it? Well, it's really important because it drives the lasers that are used extensively in semiconductor fabrication. And that means that's creating that's extending and prolonging a semi shortage that's already seen, supply disruptions to cars, supply disruptions to chip makers. So it's kind of a self-feeding cycle where you have semiconductor disruptions, and you can't get equipment to make new semiconductors. And more as these disruptions come out, and these disruptions are caused by more trade issues, more political instabilities, climate risk, all of these disasters, we're going to see more and more that chip makers need to move and adapt to the new normal. And that's true of every manufacturer out there. We all need to have ability to be more responsive, right? And how do you get the ability to be responsive? Well, we'll talk about that in just a minute, but really the fact of responsiveness, being responsive, is money. It's competitive advantage. Now, IDC shows that more and more, 35% or more of manufacturers are focusing on digital supply chain as their key transformation spending area. And it's also becoming very clear that in difficult situations like the pandemic, digitally capable manufacturers fared way better. They fared way better on profitability. They fared way better on revenue performance. And that's just par for the course now. Any manufacturer that wants to be competitive is going to have to achieve extraordinary responsiveness to supply chain disruptions. Now, that requires some key capabilities, and I'm going to throw them all out here. It requires the ability to use the cloud, to have a data infrastructure that allows you to share data across the chain, to integrate new data sources. So, for example, manufacturers that were able to integrate, for example, new infection rates, COVID infection rates, right in the start of the pandemic, they were able to drive much better decisions and could have those decisions consumed throughout their supply chain much faster and much earlier. And that led to extremely fast responsiveness, better response. AI and machine learning, that's going to be really key to add the forecasting methods because that drives forecast accuracy. That drives much greater forecast accuracy than you can achieve through traditional methods. It also lets you do things granularly, being able to, go down to the store SKU per day level and do that for over 5,000 products. You have to be able to scale. And that being able to use AI and machine learning and to be able to do scenario planning using these capabilities is extremely key. And then being able to do optimization on top of that, being able to bring in inventory optimization, customer service level optimization, and take those two priorities and optimize them together. So you're not spending too much on inventory while still hitting very, very high customer service levels. All of these capabilities are going to be key. Now, here's an important slide and my last slide. I want to cut through the hype because a lot of you might listen to me talk and say, yeah, we've heard a lot of cloud, we've heard a lot of AI and machine learning, we've heard a lot of optimization and analytics, but how much of it is real? Now, let me give you just the 30-second version. The cloud is absolutely real. You've all seen it change the way we do things. Now, it's secure. It's probably more secure than many on-premise data centers. It's cheap and flexible. The main thing is that it's scalable. And being that scalable architecture, thinking through that scalable architecture is key. And that means that you can scale, with the cloud, you can scale these capabilities across the supply chain, across your use cases, and across the loads that you have, and the amounts of data that you have. AI and machine learning is just math, right? And it's applied math. Now, you don't need a PhD to do this. It's like every other tool, but operationalization is hard. And that's why working with your trusted vendor ecosystem to actually understand how to operationalize is going to be key. And then optimization, again, automation of optimization is key. Now, you do need domain, as you do need OR experts, which, for example, CTG are experts in both the domain and OR and redesigning supply chains. You need them to be formulated well, and you need them to be, you need the solutions to be formulated and the problems to be formulated well in order to be able to automate these and to be able to run them at the performance levels that you require. But all these three are very real technologies and are being used every day. As Ed is going to show you in just a few minutes. So Ed, please take it away.
Thank you. Moving on. So our discussion, we've demystified a little bit of artificial intelligence. As you all know, it's the simulation of human intelligence, and artificial intelligence can be things like facial recognition and bank fraud and things of that nature. We're really focused on the machine learning in the green area, a subset of AI, and specifically automated machine learning, because the rate of change of data through all of the disruption that's occurring is what drives the automation requirement. So we can also talk a bit about deep learning, which is a part of machine learning for even more scalable and more highly accurate forecasts and optimization, as we'll see in just a minute. So moving on, what is automated machine learning? Well, first, let me tell you why automation is so important. It is because the rate of change of data that's occurring in your supply chain, of course, is daily, weekly, in some cases hourly. What we talk about here moving on is the historical time series data with a lot of hills and valleys here. And what we're going to do is we're going to define a holdout sample by that vertical orange line. And what that's going to do is we're going to use that as a sample against a model training period to produce a specific forecast. So as moving on, what we're going to do is we're going to apply various models against that. So as you move on, we will see models produced that include seasonality, trend analysis, and things of that nature. But the most important things that you see in those models are causal information. So causal information such as point of sale, Christmas, holidays, inventory, COVID outbreaks, as you can see in Model 3 there, out of stocks. If you're in retail or you're a CPG manufacturing company, the number of stores, customers that you apply, and promotions and things of that nature. So that data is applied to the historical data as causal and event data. And against the holdout sample, we're going to construct a series of competing models. The competing models are going to have an error metric against the holdout sample, and the one with the lowest error wins. So in this case, model 3, ARIMA, autoregressive integrated moving average, is going to take into account the causal data that you see there, Easter, COVID, inventory out of stocks, et cetera, et cetera. And moving on, that we're going to use that model to produce the backcasting and eventually produce the forecast. This is occurring against all elements of the supply chain, of all of your time series, against every SKU, location, category, brand, et cetera, combination. And if you'll move forward with the slide, you'll see that the forecast is produced. And moving forward, you will see the causal factors that might be applied to that. This is so important because, again, the data is changing. You know, what used to be monthly or what used to be weekly, now it can occur daily. So again, COVID, store opening, store closing allows you to understand the drivers of your business and allows you to, as you'll see in the case studies, to optimize your pricing, promotions, and have a more accurate forecast to drive down inventory. So moving on, a great case study is an international multinational appliance manufacturer that improved forecast accuracy, improved obsolescence by 10%, reduced inventory, and increased service levels, meaning improved revenues and things of that nature. So before this, forecasts were a rule of thumb: lacked a statistical forecast, lacked forecast accuracy. There was no measure for who was adding human bias, and the result was too much inventory and unsatisfactory service level. Just the fact that we improved the statistical forecast, reduced inventory by 20%, and increased the in-stock percentage by 10%. So profits went up, costs went down, revenue improved, happy customers, happy executives, and of course it measured and monitored the health of the supply chain. Again, this is a CPG manufacturer that has tens of thousands of customers, from small mom and pop appliance stores to the large big box stores. And then moving on, another great example of AI and ML and the benefits that you might see is one of the largest, if not the largest, CPG manufacturer. And here we're talking about promotion return on investment. So taking those promotion price capabilities that we were talking about and measuring their elasticity allowed the client to do promotion optimization, understanding what are the drivers of their business. So I know my promotions work, I just don't know which promotions work and which ones I should localize for a specific market. So they were able to include those causal factors, eliminating tons of spreadsheets, and give the marketing folks what if scenarios for what used to be monthly, now weekly S&OP. So again, improved promotional profitability. Another, moving on to another case study is an engine manufacturer. Now this one is a little bit different. Now we'll talk a little bit more about optimization of cost. So here we're talking about cost allocation for a engine manufacturer that really resulted in untimely cost allocations across just hundreds of countries and global theaters and business units. You can't hire enough planners to monitor the costs that are occurring in the exceptions. So again, applying AI to the data created accurate standard cost allocations and traceability, and improved profitability by 15% across a global theater, a global business units, customers, parts distributors. Who are my best customers? Who are my best vendors? what kind of contract should I have for maintenance? So moving on, another retailer has used AI and especially machine learning and in this case, data mining and clustering for improved assortments. And when we talk about assortments for retail, we're talking about getting the right product in the right store at the right time when we begin our season based on store size, demographics, demand segmentation. If you don't do that right, you have overstocks and stockouts, wrong sizes and wrong locations, based on customer preferences. So improving with intelligent clustering and automated assortment calculations, we were able to reduce stockouts and improve revenue by 2%, which for a large retailer is just a lot of money. And it was all done automatically through machine learning and clustering capabilities, just applying the data to the algorithms. So moving on, we then ask the questions, how do we get started? Well, I have done, in my 20 years with SaaS and my 2 or 3 years with CT Global, about 50 implementations of all kinds of industries. So you just don't buy AI ML, you really build a business case. So number one, build a business case and make sure you have an executive sponsor or sponsors that are going to validate the kind of return on investment you want to see. And number two, to the right there, build a case with IT and your business. Some of the biggest obstacles we see is not having both parties in collaboration and alignment with one another and ensuring that the data is available to support the business case, because oftentimes, quite frankly, it's not. Thirdly, do scalability and take a slice of the business case data from the past, from a holdout sample, and develop those scenarios. And then fourthly, measure and monitor those results. Use empirical holdout samples. What would we have done in September 2021 had we had the analytical capabilities that we are proposing? And then finally, once we've proved the concept and proved the value, deploy it. And I can only say that deployability is a key area that people kind of overlook, because again, you're going to be doing these forecasts and clustering and mining up applications and optimization through hundreds of stores, hundreds of locations, customers, and hierarchies. So apply that automation so you can give the decision support to the people that need it. So lastly, moving on, what are the must-haves? Accuracy, automation, and scalability. So a comprehensive set of statistical models. I can't tell you how often I hear every vendor has AI ML. Well, you've really got to ask the question that we'll see on the next page of what that really means. But the accuracy is important. Otherwise, there will be lack of trust in the analytics and lack of executive sponsorship. Automation, because the data is always changing and you want to have repeatable processes. And lastly, scalability. Scalability so that you can deploy this, so that you can deploy these analytics, these forecasts on, if necessary, a daily, weekly, and certainly monthly basis at minimum, very quickly and accurately. And the last slide has to deal with, moving on, just a quick project checklist. I won't read these to you. These will be available to you after the presentation is over. But advanced models, it's just not enough to say I have AI and ML. It's having the statistical predictive models such as ARIMA, unobserved components, neural networks, et cetera, that number two are automated so that you can create new models on the fly when the data changes, and it will change. Number three is deployability and scalability for the changing supply chain to get those decisions out to the executives who need it quickly. Number four is ensuring that you have repeatable processes to pull data from multiple data sources, not only from your ERP system, but also your pricing systems and your promotion systems, and even external data like gross domestic product and things of that nature. Number five, build an analytics culture through executive sponsorship, ensuring that decisions are made based on data, not on opinions. The famous Edward Deming saying about give me your data, not just your opinion. And lastly, you can't keep up with cybersecurity these days. It's very hard to do it on premise and to have the expertise to have a scalable and cyber secure product. So choose a cloud vendor that enables cybersecurity and scalability as you grow your business. And with that, we'll take questions and answers and we'll move forward. And buried in this presentation, if you wish, there are going to be white papers and further information from both Suraj and Ed Katz. Our emails are contained there, from things like end-to-end supply chain planning to line optimization, demand sensing, and things of that nature. So thank you very much. And thanks again, Max and Suraj.
All right, okay, so then now it's time for the Q&A. So I want to remind everybody that you guys can ask a question using the Q&A tab located on the right side of your screen. You can also click on the raise hand button located at the bottom of your screen. And if you do that, we'll be able to bring you on screen. You can switch on your webcam or your microphone and ask a question. So we have someone actually raising hand. So maybe I'll take that question right away and then we can move on to the other questions after. Hold on, I'm bringing Hi, Earl. Hi, Earl. Good morning. You're live. You can go ahead and ask your question.
Thank you, Matt. Nice to meet you, Ed and Sarah. I have a question about toward the SAS product, because it seems like the SAS product enables the customer many flexibility in terms of how you actually use the product. I'm just wondering, how does it actually work? Does the product leave the flexibility to the customer, or the customer consult you first and then you configure the product for the customers? So is it like you leave the customer to configure the some of the flexibility on the product, or I ask you about this and then SAS has a team to configure the product for me? I just use the product and then I forget about it. That's my question.
Good question. Suresh, you're consulting. You want to take that?
Yeah, I was going to say. So, Aaron, the way this works is that the tools, so the forecasting capabilities of the automation that's built in there allows a user to really get started very quickly by them. But the short answer to your question is yes, yes, and yes. There are many different ways. One is just working with the GUI functions and the capabilities that are surfaced to the customer through GUI, and that helps a lot of customers get started really quickly. But for most customers, when we actually get into a discussion, we try to find out exactly what that customer is trying to do, what their level of maturity is, and for customers that kind of want a service where we get them started, we do that. Now, typically after the first one or two use cases, our customers get comfortable enough with the solution to get started on their own. Now, for the planning piece and the optimization piece, as I've said, those can be a little more complex. And that requires a little more understanding. And we have experts like CTG here, and we have experts within SAS who can help you build out these models completely. So typically, it's one or two approaches. What I want to say is that SAS never takes the position that we want to be the ones who use and configure the product for you all the time. Our position is that we want our customers to get enabled to start doing this on their own, because that's what really brings the value to our customers.
Thank you very much.
Answer your question?
Yes.
Okay, all good. Thank you, Ara. Thanks for the question. Okay, all right. Let's move on to probably I'll take that question. This is a question from Marjorie, and she's probably referring again to the APAC region. Do you see that AI application is applicable in countries probably in Asia which are a bit unadaptable in technology now?
And if you'd like,
I'd be happy to answer that. Part of what we're trying to have you understand with automated machine learning is that all you need is the data, and the automation that I spoke of earlier is going to build through machine learning. It's going to build the models and the forecasts or the optimization themselves. Having done 50 of these, one or two of which were actually in Manila, I might add, with SAS. Data is probably the biggest gateway, the biggest obstacle, or biggest opportunity. So sometimes Suraj and team and our team get involved with making the data normalized and ready for analytics. If it's already ready for analytics, we've made it. We have what's called here in the US the easy button. Put the data into the analytics, press the button, and the AI machine learning and the automation associated with it will build the models for you and give you results right away. And our notion is to make 90% of the forecast accurate, so that you only have to touch maybe another 10%, where today you might have to touch 100% of your supply chain because you lack any forecast accuracy measurements.
And I'd like to add to that just really quickly. One of the most important things is that the technology is completely applicable, applied, and adaptable to the needs of this. And I say this because I worked, before I took on my APAC role, I spent 3 years driving AI and machine learning in ASEAN, right, including the Philippines and Thailand, etc. The one thing that I see is that that setting the expectations correctly with your executive sponsors within the company is really important, and choosing the first use case. That's really key, because in countries in ASEAN, you have a mismatch of expectations. There are people who are going to say AI is magic and will solve all our concerns immediately, like within 6 months. And there are people who are saying, well, AI doesn't work. We don't understand what it is. We don't trust it, etc. Managing the expectations between that spectrum and saying, hey, this is what the first use case is going to look like. This is what the success criteria of the first use case is going to look like. And having a technology vendor that sits with you and says, this is what is doable with the data that you have now, and this is what AI and machine learning can do with you, and making sure that expectation is normalized with your executive sponsors, that is key to getting AI and machine learning off the ground.
If I can step back just a little bit on this, you talk about all the causal factors, which, and there are new ones coming up every day, so it's very hard to predict which one. Will you say that, and again, given how difficult it is to predict all those different risks and factors happening in the supply chain, will you say that supply chain planning or supply chain in general is probably the area where you start with AI, or will you pick another area within the operation to kind of test and do a case around AI?
So I'll give you the really short version, which is, today I believe that AI and machine learning has is low hanging fruit, in the sense that in your focus, all your decisions are built off a baseline statistical forecast. If that's wrong, it doesn't matter how good your decision making is. You'll be working on bad data. You'll be optimizing towards the wrong baseline forecast. And being able to automate the process of forecasting and being able to bring it, remember I said granular, automated, and at scale. It doesn't mean that AI and machine learning will operate on every forecast. The way the SAS forecasting system works is that it looks at every granular forecast, for example, at SKU per day per store, and it takes that and it applies many different methodologies to add, ARIMA, ECM, etc. All of these different methodologies, and it applies it AI and machine learning, and it also applies blended methods, and it decides which method works well for every time series. And then it reconciles that, aggregates that up to the level of the hierarchy that you want. Now, what that means is most customers who are today doing many of them are doing spreadsheets or some other system which is not doing this level of granularity. They're going to see huge improvements in the quality of their forecast once they move to a forecasting system like this. So, I'm not sure if I'm answering your question exactly, Max, but the point I'm trying to make is that getting forecasting fixed, getting it more accurate, getting it automated is key. The second part of that is to be able to bring in scenario building and being able to integrate new data sources. But if you haven't done step one, you're not going to be able to do step two, which is being able to do new forecasts when situations change or when you see something come down the road that you want to forecast.
Okay.
Just let me say a few seconds about
what?
statistical forecasting. Is we're emphasizing statistical forecasting, AI, and machine learning, but it is part of an overall S&OP process,
Right.
where human beings really have to view that and add their own human intelligence about what's happening in the field. You know, one of the case studies I gave just very quickly was, used to be demand planners had to look at every intersection because they had an untrustworthy statistical forecast. Now they only look at 15% of their forecasts that have a higher error coming out of the statistical model, or where they know that a customer is doing something that the statistical forecast wasn't put in the model. So it is an integral and important part of the S&OP process. Thank you.
Okay. Let's take the next question. This is from Simon. He's asking, how do AI forecasts differ from other forecast generator outputs?
Well, I'm not sure I understand the question, forecast generator outputs, but I'll try. You know, AI forecasts are automated forecasts. You feed it historical and causal and event data at every level in the hierarchy. It produces the forecasts. And that's really what I consider the first and very important step that a lot of customers use. Then the next part is there's other forecasts that are generated, customer supplied forecasts, there's vendor supplied forecasts, et cetera, et cetera. And also there's salespeople in the field that are generating their own forecasts. All of those have to really go into an S&OP process. So statistical forecast is one of the things to consider. Other forecasts from customers, from salespeople, from demand planners, et cetera, also need to be considered in the S&OP process. If I'm not sure I'm understanding the question, but that's the best I can answer.
Let me try a different tack on that question, just really quick. I think the person may be asking, what's the difference between AI versus traditional forecasting methods? And I think with that, you got to kind of go into what AI is, and we probably can't hit that in the scope of this. But think of it as there are traditional forecasting methods, just like there were traditional analytical methods like linear regression and other things. And now you've got this whole new tool, a whole new set of mathematical models that actually figure out internally what the right equation is to apply. Now I say equation, but you'll never be able to get that back out of the neural network, for example. But the whole fact of the AI methodology and the AI algorithms is that they do a much better job of fully modeling what's going on underneath the data. And what companies like SAS, we spend a lot of time, effort, and R&D dollars into driving is making that understandable, making that applicable, and making that explainable once you've done a AI model to understand how that works.
Let's bring the next question. This is from Mehdi. He's asking, how can we relate forecast accuracy based on holdout data compared with measuring the performance of statistical forecasting after the fact?
So we're using the holdout data that I illustrated in that build slide to really create models and measure their accuracy at that moment in time. As the week goes on, obviously, actuals work will occur, and then you have to remeasure the forecast accuracy to see how well those models did. When a model goes stale, when a model has an error metric that's higher, so when you compare forecast to actual, this is outside the holdout sample. This is, whatever week we're in, the week of April 5th. We take, at the end of the week on Friday, we're going to look at what the forecast said, and we're going to look at what the actuals were, and we're going to see how well we did, and that is another measure of forecast accuracy. The holdout sample is just so that we can create the model and select the proper model. Kind of two separate things. They do the same thing, but in different parts of the process.
Okay. All right. Let's take. We have
great
a
question,
few
by
more
the way.
minutes.
Very good.
Yeah, let me bring a next question. We have a few more minutes so we can answer that.
Sure.
This is from Name. Do you think redesigning of supply chains with AI, cloud, and dynamic optimization in a large scale by organization will bring a significant enough improvement in the way we deal with disruptive? Hold on, let me see the question here. I'm losing track. We bring significant enough improvement in the way we deal with disruptive events or something like a pandemic?
Our reference, again, I've implemented many of these, and the feedback that we've had is that all of our customers have suffered, if that's the right word, through disruptions in the supply chain. And they would tell you that without the automated statistical forecast to alert them to the errors in the forecast, without the models being built to include COVID outbreaks, they don't know how they'd be able to survive. So while disruptions are happening and forecast accuracy isn't quite what it used to be, without it, clients would have to manually look at every SKU location combination up and down the product hierarchy. And again, this has helped bring down inventory and improve service levels, not to where they were pre-COVID, but without it, it would be a monstrous job. I don't know if you have anything to add, Suraj.
Yeah, just about I'm going to echo you, but the truth is this: many companies that I work with take a month to build a baseline statistical forecast, and it take a week to update everything. They don't even start thinking about scenarios because they're like, well, by the time we get the forecast update, the monthly forecast update up, we don't have there's no time left to do any scenarios. I mean, if you think about you can't prevent a black swan event like the pandemic. You can't anticipate it, but when it happens, you have to have 3 scenarios that you have to be able to do 10 scenarios. What if my main supplier shuts down because of a lockdown? What if this port closes down? If you can't do that kind of scenario planning, if you can't say, well, what if my demand center changes altogether and people move to another? If you can't build these scenarios because your back end, your entire forecasting and your assembly process doesn't support that, and it doesn't support that because you're still using outdated technology, it's not dynamic, it's not automated, you're behind the curve. And more, what's going to happen is, when everyone's in the same space and everyone's doing the same thing, it's fine. But a lot of companies are standing up and saying, I'm sorry, we cannot deal with this anymore. We need to automate. And when they do, the rest, everyone who doesn't is going to get left behind. That's just the way the world works.
Okay, well, we had other questions, but unfortunately, we don't have enough time to take them. So again, I want to thank you again, Edward and Suraj, for joining us. And I want to remind the delegates that if you have additional questions, you can join us again during the breakout session and the panel discussion. And also we have a WhatsApp group for other delegates where you can continue pushing your questions post-event. So thanks again, Suraj and Edward, for joining us. It was great having you. Our next speaker is actually on standby already. We are about to start, so just stay, don't go anywhere. We'll go for the next session. All right, take care. See you next time.
Thank you. Thanks for having us, Max.